we want to look at the solution to a system of equations using the Gaussian elimination method. Alright? Now, what we're going to do first of all is review the elimination method of solving a pair of simultaneous equations. Then we are going to go on to looking at the Gaussian elimination method. Now, sometimes you might have seen the Gaussian elimination method, and another time you see the Gauss-Jordan elimination method, right? Now, what happened is this, that Carl Friedrich Gauss, he lived between 1777 and 1855. He is credited with developing the idea of that elimination method. So they call it the Gaussian elimination method after him. And then William Jordan, who lived between 1842 and 1921, he is credited with extending that elimination method, where he transformed the system of equation to what they call reduced row echelon form. So that you have smaller numbers in that system of equation. Alright? So what we're looking at is the Gaussian elimination method. Now, suppose you want to solve this pair of equations. Just a revision, matter of revision here. You cannot solve equation 1 because you have two unknowns. You have x and y, both are unknowns. If you had only one unknown, then you could solve it. You cannot solve equation 2 either, because you don't know what x is, you don't know what y is. Now remember, you can always multiply an equation by a number, and you get another valid equation. Like 3 plus 2 is equal to 5. You can multiply throughout. Say we multiply everything by 2. 2 by 3 is 6, plus 2 is 4, equals 5 2s 10. And it is true that 6 plus 4 is 10. Alright? You can always add or subtract two equations once you subtract the corresponding parts. So you have 3 plus 6 is 9, plus 4 plus 2 is 6 is equal to 5 and 10, 15. 9 plus 6 is 15. You can always add these two equations. You can also subtract two equations. 6 minus 3 is 3, plus 4 minus 2 is 2, equal 10 minus 5 is 5, right? So, as you remember, when doing the elimination method, you can always multiply an equation by a number, whether it's a whole number or a fraction, or you divide. You can always add two equations to get a third equation which is valid. Now, suppose we call this equation 1 and this equation 2, and we say multiply equation 1 multiply by 2. The reason why I do this is because this has a 4x. If I get a third equation with a 4x in it, I could just subtract these. 4x minus 4x is 0, and I get rid of the x, so I would eliminate x. You remember that? Remember, this what we're doing now, is not the Gaussian elimination method. Right? It's not what is called the Gaussian elimination method. It's just the elimination method of solving a pair of simultaneous equation. Now, here, what we have is equation 1 by 2. And we have Must have a reason for doing it. We want another 4x. So 2 times 2 is 4. So we have 2x times 2 is 4x plus 3 times 2 is 6. So we go from 3y to 6y. See that? Equals, and then 28 by 2. What's 28 by 2? 2, 8, 16, bring down the 6, carry 1, 2, 2, 4, 1, 5. 56. Alright? So we have multiplied equation 1 by 2. Now let us say this leads to equation 3. Right? Now we could write this as a new equation, but what we're going to do is rewrite everything. So we replace this. This is still equation 1, you know, it's still valid. So we call it equation 1. So we rewrite equation 2. Let us draw a line. Rewrite equation 2. It is 4x plus 5y equal 50. This is still equation 2. Right? We have just changed equation 1, but instead of calling it equation 3 as we usually do, we just call it equation 1 again. Now notice what happened. We can subtract the equations and eliminate x. What we can do is say, now here I had this here, rename it equation 1, it's still equation 2. But I'm thinking you might be more comfortable calling it equation 3 if you have practiced a lot. But that's not really what we're going to be doing in the Gaussian elimination. But let us say this is what we have. Then we say equation 3 minus equation 2. 4x minus 4x, you have 0x. You eliminated x. Plus 6y minus 5y is 1y, which you could have just called y, equal 56 minus 50 equal 6. So here you can just say that y is equal to 6. Right? And then you substitute y equals 6. Now you know that y is 6. Y equals 6 in equation, which equation now? Equation 1 is the easiest, the simplest to deal with. So equation 1. So when you rewrite equation 1, you say 2 times 6. No, you say 2 times x. So you say 2x plus 3y equals, what was it, 28, equals 28. Now, x, you don't know, but you know y. So let's rewrite it. You say 2x plus 3 times 6. You know that y is 6, so it's 3 by 6 equals 28. Alright? So you have 2x plus 3, 6, 18 equals 28. So you can subtract 18 from both sides and say 2x is equal to 28 minus 18, which is what? 10. So 2x is 10. Which number you multiply 2 by to get 10? It's 5. What you could do is divide both sides by 2. And say x is equal to 10 over 2, which is 5. So you get your solutions. Y equals 6, x equals 5. Alright? Now, that was just a revision of the elimination method in solving a pair of simultaneous equations. Let's break at it from at this point, and then in the next video we go on from here towards using the Gaussian elimination method.